I'm sure that all of us have heard this story of elephant and the blind man, where every person is trying to touch a different part of the elephant and sort of trying to gog what it is that they are trying to comprehend. And I think this is the sort of a bottom line of the approach that we are proposing to analyze the antibiogram data. That where we say that we need to take holistic view of resistance now. The classical view of antibiogram analysis has always been a drug bug combination where we focus on a certain kind of resistance in a certain kind of bug. While this is helpful to a certain extent, I think we now have enough capacity in terms of data analysis as well as enough data being gathered where we can now look at resistance as a composite trait, because even molecular mechanisms of resistance sort of demand, they go hand in hand. As a proof of concept, we give an example of doing this analysis that within a One Health framework, how climatic parameters would actually affect this different kind of subtypes and their prevalence. The first panel A is showing what data we have used. So we went with the two data sets, Atlas and GEARS, and nearly 80% of the data came from Atlas and 21% from GEARS, and we chose Klebsiella pneumoniae as our organism of choice, and these 5 antibiotics which were common across these two data sets. So the B panel then shows what was the prevalence, the percentage of these different subtypes across countries. And panel C shows for the same year, the 6 different environmental parameters that we considered. Panel D is just showing one of the examples of how this regression analysis would look. We did overall 768 different regression analysis, and we found 40 of them to be significant. Already this analysis gave a couple of insights. For example, we found that when you are doing the subtype analysis, 70% of the subtypes were either all resistance or all sensitive, already indicating that, the resistance does go hand in hand. And we also found a lot of significant regression with precipitation, whatever were the measures of precipitation. We could use it for particular organisms, looking at what antibiotics are most relevant for it, and it could be very, very significant for advising a public health policy, for example, in a particular geography, if you're looking at the climatic parameters. But this composite analysis might be really helpful way of looking at how antibiotic resistance spreads and how is the prevalence.